Good afternoon. Welcome to the class on data structures and algorithms. Today, we'll be discussing about structures in C. And what is exactly a structure? Structure is nothing but it is a user-defined data type. User can define the data type. He can create his own data types. In fact, he can create data types by allowing or by combining different data items. So he can create it. And to define this structure, you should use a keyword called a struct. Struct is the keyword that is going to be used to create the structure. So look at here in the example also. In the example also. So what is that it is doing is it is creating a structure. Whatever the structure name that you give, it will go on to create a new data type with this structure. And of course, you can define the members also. Of course, you can define the members also. You can define it. So that is the thing. That is a thing that you can understand here. And the members are normal data types that are having. So members are normal data types. You can see the struct statement defines a new data type with more than one or more members, more than one or more members. You can certainly have. The format goes like this. And remember, the structure is having a compound statement. That means curly braces. At the end of curly braces, you should give semicolon. And these members are the primitive data types. So let us take one small example. So let us look into the small example. Look at here, struct student, and of course you have integer roll number, name, character of 16. So these are the two members of the structure. So as soon as you create a structure, memory is not allocated. Memory is not allocated to the structure. And if you want to get memory allocation done, so then you should create variables. You should create variables. So how are these variables? See, look at here, S1 is a variable and S2 is a variable. Variable which is of type student. Here, student is a new data type that you're creating. Student is a new data type that you're creating. And for that, you are creating two variables, S1 and S2. And you can see you can declare structure variables in two ways. And with the help of these variables only, you can able to access the members. You can access the members. The first method of creating variable, structure variable is you can certainly by using keyword struct within the main function. You can give, look at here, struct student S2. S2 is a variable. S2 is a variable. This is a structure. This is a structure that defines only the skeleton. But actual, if you want to store the value, then you should use a variable. Just like if you create a structure, you're creating a new data type. Just like integer, int doesn't create any data, but int a what happens? A gets memory allocation. A gets memory allocation. So that is one thing that you should understand. A gets memory allocation. A gets memory allocation. So that is one thing that you should understand. And of course, the second way is S2. After creating the structure student directly, what you can do, you can create variable directly like this. As soon as you create a variable like this, automatically S1 is going to be created. So with the help of S1 and S2, you can able to operate the structure members, can able to operate the structure members. So that is the thing. Now, whenever you create S1, what happens? Memory is allocated. Integer 4 bytes. 4 bytes of memory is allocated. For character, 60 bytes. 60 bytes of memory is allocated. And this is S1. S1. Similarly, as soon as you create the struct student S2, what happens? 4 bytes for integer and 60 bytes for name. So this is both combined together, they are called S2. Now, if I want to access this roll number, S1 dot roll number. As soon as I give S1 dot roll number, I can able to access this. Same way, S1 dot name, I can able to access this. So same way, S2 dot roll number, S2 dot name. So S1, S2 will get the separate memory allocation in the memory. So in order to declare these two variables, either you can do it like this, the first method, you can do it like this, or at the time of defining the structure itself, you can do it. This is the second method. So one is by struct keyword within the main function, you can use it. This is one method. Second method is by declaring a variable at the time of defining the structure. So these are the two methods. So these are the two methods that you should understand how exactly these are all being accessed. Now, very, very important. In most of the interviews also, of course, most of the interviews also, they ask, what is the size of a structure? What is the size of a structure? Suppose you have a character like this. Suppose the members are like this. One character C1, another character C2, and another integer I. So don't blindly write character means 1, another character means 1, integer 4. Never write it as 6. No, it's wrong. 6 is wrong. So remember, character is a separate data type. So whenever characters are allocated, memories are allocated in terms of words. Words means 4 byte, 4 byte. So in multiples of 4 bytes. So what happens? You can see size of the structure is nothing but sum of all the fields. Sum of all the fields. 1 plus 1 plus 4 plus in between this character and integer, there is a word means actually 4. So 4 bytes is equal to 1 word. So first data type, that is in for character, it is allocated 4. Next 4 is allocated for integer. So what happens? So it will immediately, it will never allocate memory for integer. What it will do? It will go to the next cell and it will allocate for integer another 4. So in between there is a gap. So that you call it as a padding. That you call it as padding. So this is 1, character 1, character 2, that is 1 byte plus padding 2 bytes plus for integer 4 bytes. So totally it is 8. So 6 plus 2 is what you call it as the padding bytes. 6 plus 2, totally it is 8. 6 plus 2, totally it is 8. So this is how the structure is going to be allocated. So definitely uh, it would be uh, helpful if we run this program. In the next slide, I definitely have a running program. Look at here, struct char int. So what is this doing? So you're defining a character, you're creating integer, your characters and integers as the members of a structure. The name of the structure is char int. And there is a variable that you are going to create for this structure, that is foo. So when I say printf long unsigned integer, that is size of this structure, it will return long unsigned integer, size of foo. So it will definitely give, this is 4 bytes plus 2 bytes and plus 2 bytes. 2 bytes because it is padding. So this 2 bytes are padding. So totally will display 8. So let us look into this code here. And the same, okay, I'm just connecting to the server. Yes, same thing, same program. I'll put it in the chat box so that you can also uh, even you can also execute. So you can also execute. Yes, same. You can also execute. As soon as I run this, so size of is an operator that is going to give you the total size of this structure variable. So as soon as you run, yes. So it is going to give you 8. Exactly 8. 8. So that is one thing that you should understand. It is one thing that you should understand. It is not a 6, it is actually 8. Because character, even though it is 1 byte, so it will. Now, in the next example, we'll see how exactly, in the next example, how exactly we can access the structure members. So remember, this is a structure variable, and C1, C2, I are structure variables. Structure variables. And foo is a structure members. C1, C2, I are structure members. And foo is a structure variable. Foo is a structure variable. Look at that. So these are all members of the structure. This is a structure variable, and this is the name of the structure. So you can see, of course, I want everybody to write down, this is the name of structure. And this one is structure members, and this is structure variable. So you should understand this. And these members you can access only through structure variable. So in the next example, what we can do, we'll try to uh, access the structure members, store some values into the structure members, and access it. So that we will do it in the next example. Look at this. I just clear the screen. Look at this. Here in this, the name of the structure is student. Student is the name of the structure. This is the name. And it is having 2 members. roll number and name. Roll number and name. So roll number and name, these are the two members that I have. And I have S1. S1 is a variable. Using S1, I can able to access roll number. I can able to access name. So when I create a roll number, that is S1, when I create a variable S1, what happens? Memory is allocated to roll number and memory is created to name. That is 60 space, that is name is allocated, and for this, and I can access roll number based on S1 dot. There is an operator called dot operator. This is a special operator, dot operator. We call it as dot operator. So using dot operator, using dot operator, I can able to access the members of a structure through the structure variable, Now, look at here in this example, look at here. I'm saying S1 dot roll number, is equal to 1. So I'm trying to access them. And I'm saying the value. So earlier it was not having any value. Now what happens? S1 dot roll number is having some value, that is 1. I'm storing 1. So whatever the value that I store here, S1 dot roll number, it is stored. Same way, next, Rama Satish. I want to store it. So when I want to store it, I definitely use strcpy. Copy. Strcpy is the function that is used to copy the string, that is Rama Satish, to S1 dot name. So S1 dot name, since name is a string, and if you want to copy the string, you should use strcpy. So here I get Rama Satish. So Rama Satish detail, the name is stored. It is stored. So this will store Rama Satish. Now, these two I'm using for storing, and next two I'm using it for displaying. So roll number %d S1 dot roll number. So when I say S1 dot roll number, what is there in S1 dot roll number? So that is been displayed. S1 dot roll number. Please, what is there in S1 dot roll number? That is 1. So 1 is going to be displayed. Same way, S1 dot name. So when I display S1 dot name, what is there? S1 dot name, Rama Satish, that is going to be displayed. So here I am storing, I am displaying. So that is one good thing. One good thing that you should understand. The same program, it is available in this particular link. So I just put the link in your chat box. You can also simultaneously execute along with me. So I'm just putting the link in the chat box. So you can also simultaneously execute. And those students joined just now, kindly enter your USN in the chat box for attendance sake. Those are not entered USN in the chat box, kindly enter in the chat box your USN. Okay, right. Now, look at this program. Same program. We are trying to store 1. We are trying to store Rama Satish. So as soon as I run it, so what happens? I get the result. So roll number 1, Rama Satish, is displayed. But internally, how it is memory is internally how memory is managed. So that also we'll see. So we have the same program. And same program. We have the same program. So what I'll do, I'll generate the link and just copy it. I'll put it in the chat box so that you can also run same. You can also see how, yes, you can also see. Now, look at this. I have created struct student roll number. Roll number structure is created, and name is created, and a variable S1 is created. S1 variable is created. Already it is there. So everything is there. Now I just click on next. What happens? It creates S1. Now S1 dot roll number is equal to 1. So what happens when I give? There is a value. Earlier, you observe earlier previously it was some garbage value. Look at this. Here. Look at here. Here I'm talking. Look at here. So very important. As soon as I run this particular line, so what happens next? If I click, so what happens? One value is stored. Next, str copy s1 dot name is equal to Rama Satish. So what happens? Rama Satish value is going to be stored. Rama space Satish is stored in the name s1 dot name. Now I'm printing S1 dot roll number. When I print S1 dot roll number, what happens? The value what is there in S1 dot roll number is going to be printed here. Observe here, it is printing. This is the output screen. This is the output screen. It is printing. Now, in the next line, what I am doing, name is equal to S1 dot name. So S1 dot name. As soon as I click S1 dot name, what happens? The name, whatever it is having here, it is going to be printed here. So this is the output that you are getting. So in this program, what we are trying to do is we are trying to create a structure variable and store some values into the members of the structure, store some values into the members of the structure, and print it. Then you can ask me a question, sir, what is the real usage of structures? What is the real usage of structures? There is one usage, another example I'll give. I'll create another variable called S2. Observe here, S2. Now, S1 is also a variable, S2 is also a variable. S1 is also a variable and S2 is also a variable. So, S1 is also a variable and S2 is also a variable. Look at here, S2 is created along with the definition of the structure. S1 is created inside the main, that is using struct keyword. I could able to get it. And now what I do, I store values to S1, S1 dot roll number, S1 dot name, I store. Now, what I do, S2 is equal to, I can certainly say S1. What I'm doing, I'm copying the content of S1 to S2, and I'm trying to print the roll number, S2 dot roll number and S2 dot name. See, whenever I say S1, that is, I'm copying S2 is equal to S1, automatically all the members data also gets copied to, semicolon is missing, sorry, semicolon is copied to the new variable, and the same thing you can visualize. Look at the same thing that you are going to visualize. Close. Yeah. Look at here, S2 and S1. S2 and S1. S2 is a global variable. S1 is a local variable. See, that also it is so beautifully, it is visualizing. So as soon as I click next, what happens? S1 dot roll number. S1 gets the value. Observe here very clearly. S1 dot roll number gets value. Next, S1 dot name gets the value. Rama Satish, it gets the value. Now in the next line, S2 is equal to S1. That means S1 contents are copied to S2. Look at here. Automatically, earlier the contents were not there. S2 contents were not there. Now I'm trying to display S2 dot roll number, S2 dot name. Look at that. So with one statement, you can able to copy two variables. You can able to copy two, three variables simultaneously. You can copy. You can able to copy. This is another good thing. This is another advantage of structures. This is another advantage of structures. Very, very important. Another advantage of structures. So that you should understand. That is another advantage of structures. And using structures, certainly you can return like this multiple values. You can pass multiple values. You can return multiple values. So that is also possible from functions. You can pass many values at a time. If you pass single variable, many variables gets passed to the function. And if you return the structure variable, many values gets returned from the function. So that's about the structures. So this example I've explained how to create variables, how to create values, how to store values into the members of the structure using the structure variables, how to use them, how to display them. We understood. Now, there is one more similar kind of data structure. We call it as union. Union also, it is very similar. That's 10 minutes more. Anybody, if you have not typed your USN in the chat box, kindly type it. It is very, very authentic and important to mark your attendance. So those who are joined just now or earlier, if you are not typed your USN in the chat box, kindly type it. Kindly type your USN in the chat box if you are not typed. Right. So unions, I was talking about unions. Unions are also the similar data types, just like structures. The only difference is it will allocate the memory not to every member. It will never allocate memory to not to every member. The member, suppose if a member X is having highest memory, only this gets the memory allocation. Only this gets the memory allocation. And if you want to store, only you can use. This is the common memory that is being used. So only for the member who has highest memory storage, only he will get memory allocated, and it is shared. That same memory is shared by all the members. You can see unions are also stores different types of elements, that is heterogeneous elements. The union keyword is also used to define structure same way, but union takes, this is very, very important. Look at here. Union takes the memory of largest member only. So if X is a member who will store, he will occupy larger memory, so only that memory is allocated. So that what happens, the other members, so that other members can share the allocated memory, can share the allocated memory. Very, very important. This is the only difference between structures and unions. Very, very important. Structures and rest all same. You have to create a structure variable just like that. Union variable also you should create. And using union variable, you should access the members of the union. Same way you have to do it. And observe here also I'm using union character int. So earlier it used to show, when I run this program, it used to show here there was a structure. It used to show this is 1 byte, this is 1 byte, 2 plus padding 2, 4 plus 4, 8 it used to show. But now memory is not allocated to everyone. Memory is not allocated to everyone. Memory is going to allocate to only the highest member. Who is the highest member? Integer I. So integer I will store only 4 bytes. And this 4 bytes, it is shared for C1 also, it is shared for C2 also, it is shared for I also. So same memory is shared for all 3 members. All 3 members share the same memory. So same thing it has been, look at the example here. The example, so I just clear the screen. Yeah, look at the same. Instead of structure, this I have already shared in the chat box, your message chat box. Yeah, same thing. So if I run this code structure, if I run this code structure, it is showing 8 structure. Same thing I am modifying. It is not structure, it is union now. It is union now. Now union will allocate memory to only highest memory element, highest member. So that is I will store integer, that is 4 bytes. It will be stored for only 4 bytes. See, look at here. It is only 4 bytes of memory. It is being used, allocated. And this 4 bytes are allocated and it is being shared among all members of the union. So for this, let us look into another example. Look at this example. The same. I have created union here. I created union. I have modified this union. Same. S1 is the variable. Roll number, name, everything is same. Roll number is 1. Name is Satish. I'm just storing it. Now, roll number, S1 dot roll number, S1 dot name. So I'm just printing it. Now, let us visualize this program. So let us visualize this program. The same code, I'll be just putting it in the chat box link. You can also run along with me. Now, look at here. Union I have used S1. As soon as I store, roll number is 123, 123 gets stored. And memory, see, integer is 4 bytes. Integer gets 4 bytes of memory. And name gets 12 bytes. So what happens? So memory is not allocated to 4. It is allocated to 12. It is allocated to 12. So 12 bytes of memory is shared among integer and roll number. So as soon as I run this example, so what happens? 123 is stored first. Later, what happens? This 123 is replaced by Satish. And as soon as I print roll number, S1 dot roll number, some garbage value is going to print. You can see, actually 123 should have been printed here. But since Satish is overlapping 123, what happens? This old roll number is gone and some garbage value is printing. Whereas Satish is already printing. Now I modify this program. I'll print this just after storing. Now you see, as soon as I store, I print it. So what happens? So it will come as usual. And later, what happens when I change the value, Satish, okay, S1 dot Satish, that will come automatically. You can see. Yeah, 123 is printed. And this 123 is again modified by Satish. It is modified by Satish. So same memory is allocated. For both the variables, both the members. So same thing you can see in the visualization. I think visualization is not there. So you can certainly check in the visualization. Same thing it is, you can check it in the visualization. So 1 minute left. Those who have not entered your USN in the chat box, kindly enter your USN in the chat box. Right? Okay. So as soon as I visualize this program, what happens? Observe now, memory, even though it is allocated, it is being used by only one member. So 1, 2, 3 is stored, and 1, 2, 3 is printed. And next, the same is being used. And you can see Satish is used, which is replaced by this integer. Integer 1, 2, 3 is gone. You can see it is gone. And Satish is printed. Satish is stored, and Satish is going to print. So look at here. So same memory is shared among these two variables. That is only difference between union and structures. Many times in interviews they ask. So here is the difference. The size matters. Second one, memory. So it is a unique storage memory in the case of structures, whereas in the case of union, only individual members will not get allocated. Only highest memory will get memory allocation. That's all for today. Next class, we'll discuss about last topic, that is pointers. Thank you. And all the class recording notes is available in this particular website.